All right, everybody. Welcome to another deep dive.
Yeah.
Today, we're diving into the world of computer networks.
Ooh, exciting.
I know, right? So many people want to know more about this.
Yeah, people always ask, like, how does the internet actually work?
Yeah. Like when I click a link, what's actually happening?
Or like, what is all this stuff about fiber optics and cables?
Right. Is it magic? No, not magic. And we're going to learn all about it today.
Exactly.
We got a really cool university lecture on computer networks that we're using as our guide for this deep dive.
Much more fun than actually being in a lecture hall.
For sure.
Definitely.
Okay, so let's jump right in.
Let's go.
What is a computer network?
Okay, so basically you got a bunch of devices,
Uh-huh.
and they're all connected together,
Okay,
so they can talk to each other and share information.
like my home Wi-Fi.
Exactly. That's a perfect example of a network.
Okay, cool.
But it goes way beyond just Wi-Fi. We're talking everything from, like, your Bluetooth headphones connected to your phone,
Mm-hmm.
all the way up to those massive data centers that power the internet itself.
Oh, wow, so there are like levels of networks.
Yeah, totally.
Okay, so we've got these networks. They're made of different parts, right? What are those parts?
Yeah, so think of it like building a house.
Okay,
You've got those building blocks. Those are your devices themselves.
right.
Your laptop, your phone, your smart refrigerator these days. Everything's connected.
Uh-huh,
And then you need ways to actually connect them physically.
right.
So those are your connectors,
Okay.
like Ethernet cables or Wi-Fi signals,
So it's like the internet has its own plumbing?
kind of.
Yeah.
You need those pipes to get that data flowing.
That's a great analogy.
And then you've got protocols and standards.
Okay.
These are like the rules of the road that make sure that all these devices speaking different digital languages can actually understand each other.
So like a universal translator for the internet?
Exactly. Without protocols, it would just be chaos.
Total digital gibberish.
Right. Nothing would work.
So you mentioned something about different network designs.
Oh, yeah.
How are these devices actually physically hooked up?
So there are a few different ways to design the layout of a network.
Uh-huh.
You've got a star network where everything connects to a central hub,
Okay.
a bus network where everything's on a single line,
Okay.
and then a ring network.
Okay.
Whereas a ring, it's all connected in a circle.
I like that. So it's like choosing the seating chart for your network party.
Yeah, exactly. Some layouts work better for different situations.
Okay.
And then you also have to think about the scale of the network.
Right, because you've got tiny networks and huge networks.
Exactly. So like you've got personal area networks or PANs.
Okay.
Those are tiny, like your Bluetooth connection with your headphones.
Okay.
Then you've got local area networks or LANs. LANs. Those cover a small area like your home or your office.
Okay, so that's my personal internet kingdom.
Exactly.
Or your domain.
And then things get bigger.
Then we get into the really big leagues. We're talking like worldwide.
Yeah, so we've got metropolitan area networks.
Yeah, it is.
Those cover like a whole city.
Whoa.
And you've got wide area networks.
Wands.
WANs can span entire countries.
Oh, wow.
And then, of course, the granddaddy of them all.
I'm waiting for it.
The internet.
The internet. It's kind of a big deal.
Just a little bit.
Okay, so we all use the internet every single day. I bet most people have no clue how it actually works.
It's kind of magical when you think about it. It's like this giant puzzle
Okay.
with billions of pieces all fitting together.
Billions.
Billions.
Mhm.
We're talking billions of devices
Yeah.
worldwide, all constantly communicating and sharing information.
I can't even picture a billion of anything.
It's a lot.
That's a lot of hardware to make that happen.
Oh, yeah. So you've got routers.
Okay.
Those are like the traffic cops of the internet.
Okay.
They're directing data where to go.
Uh-huh.
And then you have those fiber optic cables,
Okay.
incredible strands of glass.
Glass.
Wow. They're carrying information as pulses of light,
Light pulses.
almost at the speed of light itself.
Seriously?
Yeah. A single fiber optic cable can carry something like the equivalent of 3 million phone calls at once.
No way.
It's insane. It's like having a digital superhighway,
I'm so...
moving information at breakneck speeds.
So it's not magic, it's just light.
Light and glass, and some really clever engineering.
Okay. That is really impressive.
They're pretty cool.
All this hardware comes together to make the internet work. I mean, it can't just be cables and routers randomly scattered around.
No, definitely not. There's definitely a structure to it.
Okay, good, because if it was random, that would be scary.
Yeah, a little chaotic.
So how is it structured?
So think of it like a city.
Okay, I like this analogy.
You've got the bustling downtown core.
Okay.
That's like the network core.
Okay.
All those high-speed connections, major routers all hanging out together.
Okay.
And then you have the residential areas.
All right.
That's the network edge.
Oh, so that's where I live.
That's where you are. That's where we connect with our devices.
Okay, so I'm in the suburbs of the internet.
Exactly. You're on the outskirts.
Okay, so how do I get from the suburbs to the downtown core?
That's where internet service providers come in.
ISPs?
Yes. Those are the companies you pay for internet access.
Right.
So they provide that connection.
They're like my internet landlord.
Exactly. They're giving you a digital address,
Okay.
giving you a way to get onto that highway.
So what about like those giant companies like Google and Netflix? Where do they fit in?
They're like major corporations.
Uh-huh.
They've built their own private highways on the internet.
Really?
Yeah. They're called content provider networks.
Content provider networks.
Yeah. And they want to make sure their data gets to you as fast as possible.
Right.
So they've invested in their own infrastructure.
So like Google built an express lane on the information superhighway just for YouTube videos.
Pretty much.
Wow, that's pretty smart.
They've got to get those cat videos to you somehow.
That's true, and not just cat videos.
Yeah. Not just cat videos.
Think about all the data centers
Yeah.
that store our emails and our photos and documents, everything we do online.
Everything. It's a mind-boggling amount of information.
I'm officially overwhelmed,
It is a lot to take in.
but incredibly curious.
Good.
How does all this information actually travel on the internet?
That is the million-dollar question.
Right. Like when I click a link
Uh-huh.
or I send an email,
Right.
what is actually happening? Does it teleport across the world?
That would be cool.
Yeah.
But not quite teleportation.
Okay.
It is pretty close, though.
Okay.
I'm intrigued. So remember those data packets we talked about?
Vaguely.
We're going to get much deeper into data packets.
Okay, good.
But they're really the key to understanding this whole data transmission thing.
Okay, I'm ready.
All right, so imagine you're sending a pizza across town.
Okay.
Instead of sending one giant pie,
Right.
you slice it up,
Okay.
you put it in separate boxes.
Uh-huh.
Each box is a packet.
Okay, so my email is getting sliced and diced like a pepperoni pizza.
Kind of. But digitally, of course.
Digitally,
Each
okay.
packet contains a piece of your message,
Okay.
along with some important information like the address and instructions.
So it knows where to go.
Exactly.
Okay.
And then these packets, they travel across the internet.
Okay.
They hop from router to router
Uh-huh.
until they reach their destination.
Okay, so the routers are kind of like little post offices.
Yeah, they're sorting those packets and figuring out where they need to go next.
They're reading those digital addresses.
Exactly. Each router uses something called a forwarding table.
Forwarding table.
It's like a map that tells the router which path to take to get that packet closer to its destination.
Okay.
So yeah, it's like a giant postal service.
That's a really good analogy.
And just like a postal service, the internet can experience delays,
Oh, no.
right? If a router gets flooded with too many packets all at once,
No.
those packets have to wait in a queue.
So, like, when my internet slows down.
Exactly. It's like digital rush hour.
Oh, I hate digital rush hour.
All those packets stuck in traffic.
That's a good way to put it.
And sometimes if the queue gets too long, packets can even get dropped or lost.
Gasp. Like a letter getting lost in the mail.
It happens sometimes.
Is there anything that can be done to, like, prevent those digital traffic jams?
Yeah, so network engineers are constantly working on ways to like optimize traffic flow and prevent congestion.
Okay, good.
They're developing new routing algorithms, increasing bandwidth,
Okay.
implementing all sorts of fancy techniques to keep the data moving smoothly.
So they're, like, constantly building new highways and traffic management systems for the internet?
Pretty much.
Wow, those engineers must be busy.
Oh yeah, they're always working.
So we've talked about how data travels across the internet,
Uh-huh.
but now I'm curious about how we, the users, actually connect to this whole thing.
Right, so we're back to that network edge,
Back to the suburbs.
back to the suburbs, where we all live.
And there's a variety of ways to access this digital world, right?
Absolutely.
Yeah.
So many different ways to get online.
Okay, cool. So let's talk about the different options for like home internet access.
Okay.
I know we've got cable, DSL, fiber optic, all those things.
Yeah, those are the usual suspects.
Mhm.
Each one uses a different technology to connect your home to the internet service provider.
Right.
It's like choosing a transportation method for your daily commute.
Okay.
You could take the bus, the train, drive your car, ride a bike.
I get it. So choosing my internet connection is like choosing my ride to work.
Exactly. Each option has its own pros and cons.
Okay, so what are the pros and cons? Let's break it down.
Okay, so cable internet is super popular because it's widely available
Uh-huh.
and it offers pretty good speeds,
Okay.
but it's a shared network.
Oh, what does that mean?
So that means speeds can slow down during peak hours.
Oh, so like rush hour on the freeway?
Exactly.
Yeah.
When everyone's trying to get online at the same time.
I hate when that happens.
It can be frustrating.
Okay, so what about DSL?
DSL uses existing telephone lines. So it's often more affordable than cable,
Okay.
but it can be slower and less reliable.
So slower and less reliable.
Yeah, it's kind of like taking the back roads instead of the highway.
Okay, so cable is faster but can get crowded, and DSL is slower but might be more reliable.
Yeah, that's a good way to think about it.
What about fiber optic? I keep hearing that's like the holy grail of internet connections.
Fiber is definitely the speed demon.
Okay.
Blazing fast speeds, high bandwidth.
Uh-huh.
It uses pulses of light to transmit data, remember?
Yeah.
So it's like having a private jet for your internet connection.
Sign me up. But it's probably really expensive, right?
It can be, yeah, and it's not yet available everywhere.
Okay.
But if you're a heavy internet user
Uh-huh.
and fiber is an option in your area,
Mm-hmm.
it's definitely worth looking into.
Okay, so like for people who live in rural areas where cable and fiber aren't available,
That's where satellite internet comes in.
satellite internet.
Yeah.
Okay, cool.
It's a good option for those hard-to-reach places. But it can be expensive and have high latency.
Latency. What is latency?
So latency is the delay between when you send a request and when you receive a response.
Oh, okay.
It's measured in milliseconds, and the lower the latency, the better.
So for things like video calls and online gaming, you want low latency.
Absolutely. Yeah, high
Yeah.
latency can be really frustrating.
Okay.
Makes everything feel slow and sluggish.
Like trying to have a conversation with someone who takes like 5 seconds to respond to every sentence.
Exactly.
I hate that.
Super annoying.
Okay, so we've talked about home internet access.
Uh-huh.
What about mobile networks? How do our smartphones connect to the internet?
So mobile networks use a different technology
How?
called cellular technology.
Cellular technology.
Instead of cables, they use radio waves
Radio waves.
to transmit data between your phone and cell towers.
Oh, wow.
So it's like having a network of invisible hotspots covering the entire country.
That is pretty cool.
It is.
So it's like a giant web of wireless connections keeping us connected on the go.
Yeah, exactly. And that's where 5G comes in.
Dingo.
Uh-huh.
5G is the latest generation of cellular technology.
Right.
It promises significantly faster speeds,
Ooh.
lower latency,
Okay.
and greater capacity than all the previous generations.
Wow. So it's like upgrading from a dirt road to a superhighway for mobile data.
That's a great way to put it, yeah.
That is cool. So like self-driving cars and all that
This
stuff.
5G is going to enable all sorts of new technologies.
That's so exciting.
It is a very exciting time.
But even with all these advancements, I imagine there are still physical limitations to like transmitting data.
Oh, yeah. Definitely.
Right. Whether it's cables, radio waves, even light pulses,
Right.
there's got to be challenges to overcome.
Yeah, for sure.
Okay, so what kind of challenges?
Well, you've got things like signal interference,
Oh,
distance limitations,
Ah.
even the speed of light itself.
wow.
These are all factors that engineers have to consider when they're designing these networks. So it's like a constant battle to make the internet faster, more reliable, more accessible to everybody.
Exactly. Yeah, it's a never-ending quest for better connectivity.
That is wild. I'm glad there are people out there who understand this stuff.
Me too.
So we've covered a lot of ground today,
We have.
from how data travels in packets to the
Oh.
different ways we access the internet. It's amazing to think about all the complexity that goes on behind the scenes.
It really is.
Every time we click a link or send a message.
It's mind-blowing.
Yeah, it's kind of humbling too when you think about it.
It is.
And we've only just scratched the surface.
We've just begun.
I know, there's still so much more to explore.
Like those all-important internet protocols.
Oh, yeah, those protocols.
They're the unsung heroes.
Okay, you've piqued my curiosity again.
Good.
I'm ready for more.
We'll delve into those protocols in part 2 of our deep dive
Okay.
and uncover even more secrets of the digital world.
I can't wait. So everyone stay tuned.
Yeah, don't go anywhere.
We'll be right back with part 2 of our deep dive into computer networks.
See you soon.